I'm Anil Kumar, and here is question number 10, page 345 from Nelson, transformation of trigonometric functions. Now the question here is, a pendulum swings back and forth 10 times in 8 seconds. It swings through a distance of 40 centimeter in each swing. Sketch a graph of this motion for 2 cycles, beginning with the pendulum at the end of its swing. Write an equation to model the situation. I have changed this question a bit because the second statement I've changed it to make it exactly what I mean. It swings through a distance of 40 centimeter in each swing. Okay, that's how I have changed it. Now let's go back to this equation, rather the question. It is a pendulum swings back and forth 10 times in 8 seconds. So what is the time period? So time period should be, it says 10 times in 8 seconds. So one time in how many seconds? So the time period is 8 over 10, right, seconds, which is, let me write it in decimals. Of course it is 0.8 seconds, and in fractions we could simplify this dividing by 2. We get this as 4 over 5 seconds, right? So either way we could write it, right? So the time period is 4 over 5 seconds, or 0.8 seconds. Once we know the time period, in the sine or the cosine function, whichever you want to use, we can write the trigonometric equation with k as 2 pi by t, right? So k will be 2 pi by, fraction is good to use here, 4 by 5. So that gives us 10 pi by 4, or 5 pi by 2 as the k value, right? Now let's try to sketch it and then we'll get back to the equation. Now let's try to understand also what the situation is. Let's say this is the pendulum and it is kind of swinging, right? So it says that sketch a graph of this motion for 2 cycles beginning with the pendulum at the end of its swing. That means, let us say this is the end of the swing. So we will kind of consider like this. That is how we'll consider, right? So to start with, we have a maximum, and then it goes to the minimum, taking the right side to be positive and this position to be 0 and the left side to be negative, right? So based on that, we are going to graph our sine wave, right? So in this particular case, since we are starting from the maximum value, we will say the maximum value is kind of like this. It goes to 0, then comes down, and then kind of climbs up, then comes down, and then kind of climbs up like this. So that completes 2 waves for us. As you can see, it does 10 times in 8 seconds. So one time in 8 divided by 10. So the time period is 8 divided by 10. So for one wave, the time period should be 0.8, correct? So we have time period as 0.8. So of course, half of that will be 0.4 and half of that will be 0.2, and this should be 0.6 for us, right? So that is one wave. 2 waves will be completed in 1.6 seconds, right? So this is time in seconds. Here we have amplitude, or the function f of x, and the units here will be centimeters, in centimeters. Now the statement which I changed into is it swings through a distance of 40 centimeter in each swing. So that means total is 40. So it goes one way 20 centimeters and come back 20 centimeters. Do you see that? So basically it is from here 0, it goes to 20 and then comes back to 20. So in one swing it goes through a distance of 40 centimeters. That is what we are saying. So it goes up by 20 further away and comes down to minus 20, right? So when we start from here, we considering this position as 0. We say it is up at a position, highest point, And in this one swing, from here 0 to the negative least point, the total distance is 40. That is what we're trying to say. It swings through a distance of 40 centimeter in each swing. That's what we're trying to say. Okay. And then it comes back 40 again. So total distance will be 80 in one swing. Right? That's what we're trying to correlate with. So in that case, the amplitude for us is 20 centimeters, right? Now, we could write this. So the two waves are drawn for us. So we have to write an equation to model this situation. To write the equation, I'll prefer to write it as cosine function since it starts with the maximum. So we can write this function as f of x equals to amplitude is 20 cos of. Now time period or k value is 5 pi by 2. Cos of 5 pi by 2 times t, right? So that becomes the cosine function. But in case you want to write the same equation in sine, in that case, let us see what happens before this. So if you continue this graph on the left side, you'll find from the symmetry that it should be at minus 0.2. So the sine really starts 0.2 seconds earlier, right? So the function could also be written as 20 sine 5 pi by 2, which is the k value, t plus 0.2. Correct? So that is the way to write it as a sine function. So both ways you could represent this particular pendulum motion in the form of an equation. I hope that helps to understand, right? So this statement did really create confusion. It's still not very clear to us, but we are assuming that the total distance in one swing, maximum to minimum, is 40 centimeter. Based on that, we have derived this particular formula. Okay, I hope that helps. Thank you.